Trigonometry, section 2.4, solving right triangles. Let me begin by saying if you have a tool to measure, let's say you've got a straight edge, and this tool is marked off, let's say in inches, but not any half inches or quarter inches, or it's just inches. What's the closest, according to our scientists, that you would be able to measure anything with this straight edge? Well, according to them, you have to do half of the unit that you're given. In other words, you're given 1 whole inch here. We'll call this inches, right? And so the best you can do is measure within a half inch. You might say, well, I can do better than that. Well, for scientific research and other things, no, they don't want you to do that. They're saying, nope. If you want to measure something and it comes out from here to right here, you can't say almost 5. Is it closer to 5 or 4.5? It's one of the two. But if you say it's closer to 5, then you've got to use 5. You can't use 4.8, anything like that. You have to say 5 inches. Anyway, that's what I remember from my chemistry and physics stuff. Continuing with that, that's some of the logic we're going to use with our measuring of right triangles and coming up with measures for that. But there's also, on page 69, a table. That table has the angle measure, like degree and 10 minutes, or 1/10 of a degree, and to the nearest minute, 1 minute, or 1/100th of a degree, and the 10 seconds, or the nearest thousandth of a degree. Those are the sort of the different things that you'd be able to measure to. Your answer for significant figures should be 2, 3, 4, 5. This is the table they give us. So this is relating the degree measure, the angle measure, to the length, linear measure. So angle and linear are the two we're trying to do here. If you have something to the nearest degree, you should be using significant figures to 2 decimal places, 2 sig figs, not decimal places. So that's the next thing. What in the heck is a significant figure? Well, if you have 0 here, anything, I guess, to the left of 0, this is the decimal point, right? Once you get to the right of the decimal point, anything that you have between that decimal point and the first non-zero value, those two are not counted. This is point, right? You start counting this, anything between 2 non-zero values, and we're talking about zeros here. That's which ones do you include and which ones do you not. So we count this 5. We count the 0 because it's between 2 non-zero. We count the 2 and the 3. Do we count this last one? Yes. This one's significant because, in one sense, you say, well, why did you put it on there if you didn't want to go that far? If you didn't want to go that far, you should have left it off. But you put it on there, and therefore you need to count it as a significant figures. This has 5 sig fig. Now there's some examples then up here for degree measuring stuff. So these degree measures, if you have 62 degrees, then you should use 2 sig fig. If you have 52 degrees and 30 minutes, then this is the nearest 10 minutes, right? Then the 1/10 of a degree, and you should use 3 sig figs. 1/10 of a degree would be, say, 60.4 is what was in the textbook. The nearest minute, you'd say 81 degrees, they'll say 48 minutes. So this is nearest 10 minutes. So you'd be 20s and 30s and 40s. This will be the nearest single minute, or 71.25 is what the book talked about. That's 1/100th. Use 4 sig fig. And the nearest 10 seconds. So if you do 10 degrees, 11 minutes and 20 seconds, here you count by 10s, 20s, 30s, 40s. You use 5 sig figs. Now, are we going to use all that stuff? Not much, but you'll find, I think, at least the way I interpret this, the book is going to answer things a little incorrectly too. So, just so you recognize that significant figures are going to be part of this, I will try to give you on a test a little more guidance on what you should choose. So, how do you, exact numbers don't count, or don't affect sig fig. So if you're doubling something like circumference is 2 pi r, just because 2 is one significant figure, don't use that as your guide. It's the stuff you're measuring, or the stuff that you're given somehow to measure. Don't use pi. That is an exact number in a sense. That this has all the decimals in it and they go on forever, so you don't want to use that for sig fig. But this 2 and the pi are things that you don't include in your calculations of significant figures. They're not going to give you too few or too many of those to choose from. So exact numbers, whatever exact might mean, pi is exact only because we can't write them down. Okay, so the way to solve any triangle, or right triangle rather, we're going to always use C for the right angle, and A and B are going to be the other two angles in that right triangle. The sides opposite are the little letters, so a little a, a little b, and little c, hardest one to determine. And when you solve a right triangle, you're going to have all the angles and all the sides, all 6 parts listed. That's what solving a right triangle does. We're also going to look at, in the next section, I guess, too, a little bit, the problems that you could use solving right triangles to help you solve. One of those for this really goes back to the idea of these parallel lines. If you're standing here, waving at everybody, this is your line of sight, and you see something, I don't know, an airplane is up here. From you to that airplane, there's an angle from the horizontal. This is the angle of elevation. From the plane down, it has this line of sight, the horizontal. This is the angle of depression. Goes down, this goes up. Just so you can get those words straight. But it's better to take a look at some example problems instead of just explaining all this. So on page 72, number 4, the instructions state referred to the discussion of accuracy and significant digits for these problems. Number 4. Let me write that down. The top WNBA scorer, Women's National Basketball Association player Cappie Pondexter of the New York Liberty received the 2010 award for the most points scored, 729. Question is it appropriate to consider this number between 728.5 and 729.5? Why or why not? So 729 points scored, but if we're scoring my whole points, shouldn't we then measure this between 728.5 to 730.5? I'm sorry, 729.5? Shouldn't it be those half units? Because we can't measure exactly. Well, what they're trying to show us with this problem is some things are not going to be this continuous line that you need to worry about. It's not like the measuring stick that we had before with inches measured on it. This one is you either scored 729 or 728, not a half. Now, some other things, perhaps, if you had a half of a sack or something like that in football. But for this situation, it's 729. And because these are exact numbers, we just use them as they are. So you need to write down something. The question, number line, exact numbers. Give me something to give you your 4-step points from. Okay, how about number 10? Here it is, solve each triangle. 2 sides are given. Give the angles in degrees and minutes. So for number 10, this is a right triangle. This is X, this is Y. These are the, I guess, X, capital Y, and capital Z they're giving for this. 89.6 centimeters. It says give angles in degrees and minutes. So this is the angle 47.8 degrees. So solve each right triangle. We need angle X, angle Y, and angle Z. Well, that's a good one. That's going to be 90 degrees. Little x, little y, and little z. Well, little z we also know it's 89.6 centimeters. Don't forget the centimeters. Angle x is 47.8 degrees. I don't know why they say give angles in degrees and minutes when they give this angles in decimal. So this is what I'm going to say. Maybe this is number 10. I won't be able to look it up. I would follow what's given, not the 90 degrees. That's an exact answer. But this angle y I would do to the nearest 10th of a degree. Okay, so how do you find these? Well, let's see. We know this angle. We know the hypotenuse. We need the opposite and the adjacent. We can use the trig function. We know that the opposite over the hypotenuse is the sine of this angle. So the sine of 47.8 degrees is the opposite x over the hypotenuse, 89.6. So 89.6 times the sine of 47.8 degrees is x. Let's figure out what that is. Clear out the old stuff. 89.6 times the sine of 47.8, and it gives me 66.3760. Well, write it down. 66.37609. Now, how many significant figures should I use? Well, in this case, z used nearest tenth. So that's what I'm going to do. I'm going to put in for x 66.4 centimeters. And that's what I'm going to suggest for all your problems. If this goes to the nearest tenth, follow that. If you don't have any values for these sides, then you might have to use the angle to help determine what that significant digit should be. Otherwise, use the same for each of these. Nearest tenth for this too. How do we find that angle y? Well, we know that 90 and 47.8 add up to 9 and 4 is 13, 137.8, and 180 minus 137.8 gives you 42.2 degrees. How do we find y? You can use the Pythagorean theorem because this is a right triangle, but let's use some more trig because it's a little more fun, and you got to practice it anyway. So, since I've got x now, the 66.4, but I've got this angle and that given side, so I'm going to use that with y. That's the adjacent and hypotenuse. So I know that the cosine of 47.8 degrees is the adjacent y over the hypotenuse 89.6. So 89.6 times the cosine of 47.8 is what y is. 89.6 times the cosine of 47.8. So I get 60.186. I just need to go to one decimal place, 60.2. So I can find the color again. Centimeters. So that's solving a right triangle. Do you get 10 steps? You get a bunch of steps. You get at least 4 though, certainly. Okay, how about number 36? These problems are supposed to solve each right triangle. C is the right angle. They give us, let's write these down first. Angle A, angle B, angle C, we know that's 90 degrees. Little a, little b, and little c. For number 36, they give us angle B is 82.51. 82 degrees, 51 minutes. So I'm going to do all my angles, except for 90, to the nearest minute. Side C is 4.825. So 4.825. And now I have to find angle A, side A, and side B. So, how do you do that? Well, first you draw a picture. I'm going to put angle A down here because it's the way I'm used to seeing it. Oops. Angle A, here's angle C and angle B. Side A, I don't know. Side B, I don't know. Side C is equal to 4.825. I don't know angle A. I do know angle B. That's the 82.51. So when I reference, if I want to find side B, That's the opposite. I've got the hypotenuse. Sounds like sine. So the sine of 82 degrees, 51 minutes, and notice I'm using the angle I was given and the side I was given, equals the opposite b over, that's hypotenuse, 4.825. So 4.825 times the sine of 82 degrees, 51 minutes is b. While we're here, let's do the other one. The cosine of b is the adjacent a over the hypotenuse. So the cosine of 82 degrees, 51 minutes is the adjacent a over the hypotenuse, 4.825. Or 4.825 times the cosine of 82 degrees, 51 minutes. That's what a is. Angle A, we don't always have to go with 180 degrees. We know this is 90. These two have to add up to 90. So 90 degrees in minutes, you want to subtract the 82, 51. Now I'm going to do that first and then bring my calculator in. This 90 becomes 89, and the 1 degree makes 60 minutes. So 60 minus 51 is 9 minutes. 9 minus 2 is 7, and 8 minus 8 is 0. So 7 degrees and 9 minutes is angle A. Now, to find the two sides, I need my calculator. Let's clear this out. 4.825 times the sine, 82 degrees, 51 minutes. 82 second apps, 1 for degrees, 51 second apps, 2 for minutes. That's what B is going to be. And it gives me 4.787. Let's see, let's write it here. 4.787. Since they want 3 places here, I need to go one more. 7874. So it is just 787. That's B. Now they say, oh, these are meters. Now, for part A, it's going to be almost the same. The only thing, notice, that changes here is cosine. So you don't have to, you can type it all back in. If you do second enter, it brings back the previous command. Also, on the newer operating systems, you can use the arrows. But once you get there, you can change some things. Notice how it jumps from the angle all the way to the beginning of sine, if you can see that. 82 all the way over sine, because I'm going to overwrite this sine with cosine, and that's the only thing that changes. That's the only thing that changes here, so that this is 0.600555. That's what A is. I need 3 places, so I need to have a 1 there. 0.601 meters. And I've solved that. Let's suppose that your good friend said, gosh, I need to know the diameter of the sun. And you said, well, I don't know, we've got to have some information. And he says, well, I remember that the distance from the sun to the earth, and we're going to use the centers of these masses as the points where you locate that. I remember it's 92,919,800 miles. 92,919,800 miles. Remember that. Here's the earth. let's see, we got to get the sun going here. There's got to be some yellow in here, and then some orange maybe. That was more skin tone. Here's some orange that might be better here. Okay, but now the earth is blue and green, so we'll put some blue in and then fill in the rest with some green. Okay, I don't know if you can see that. Anyway, that's the earth. And you say, well, we should be able to figure this out. What is this distance, that diameter? Well, let's see. And what I want to emphasize is that this is not drawn to scale, okay? In case you were wondering. So, if we know this distance and we know that, how do we find this? Oh my God. Well, we can find, because this is not a right triangle, it's an isosceles triangle, but there is a right triangle here. And we can find then half of this D because it's one of the legs. But we need to get on here and measure. Say we measure from one side of the sun to the other side of the sun. Try not to look into it too much. But let's say this is 32 degrees, or 32 minutes. 32 degrees is too much. Now, we just need then to take half of that because that's what this should. So we need essentially a right triangle with 16 minutes as the angle, 1/2 of D as that leg, and 92,919,800 miles here. So, now if we've got the opposite and the adjacent, which trig function? Tangent. Tangent of 16 minutes, that's important, is the opposite, 1/2 D, over the adjacent, the 92 million, and I'm not going to. Okay. So we're going to solve this for D. So it's the 92 million, I'm just going to call it 92 for now, times the tangent of 16 minutes is 1/2 D. Multiply both sides by 2, and double that 92 is 184, times the tangent of 16 minutes. That's what D is. Let's see if this works. So let's clear this out. 184 times the tangent of 6. I wonder if it'll let me do this. I don't know. I haven't tried this one. Second half's 2. See if it'll give me an error here. Yep, it does. I wondered about that. It says quit, but if you go to, it'll try to put you where there's the possibility of an error. What it wants for this angle is degrees also, even if it's 0. So you have to put in 0 second angle degrees, and then the 16 second angle minutes. Otherwise, it'll give you an error. So, oh, you know what? I can't use 184. I got to use that whole thing. So, let me go back to this thing. And it's really 2 times 92,919,800 times the tangent of 0 degrees, 16 minutes. Now let's get, because that was too small of a number. So this is 8649.43.0. 0.0189 miles. Now, you can't use that. You weren't that close when you're measuring. Your friend was off a bit, right? So really, this did it to the nearest 100 miles here. So really, I think it's better to say this is 864,900 miles. That would be the way I would look at it, because this is to the nearest 100 miles. So round that up to 43. That's all there is to section 2.4 as far as what you need to do the problems at the end of the chapter. We'll do 2.5 in the next video.